Here is the Cirrus Data Cloud portal running Cirrus Migrate Cloud. Cirrus Migrate Cloud is a data management as a service app that allows you to migrate and/or protect any block storage anywhere. Here we see the name of the project, the owner, and basic information on the project. Here we'll enter a project name, a short description, and click Create or Update Project. You can add new members to the project to manage the project either as an administrator or as a monitor by sending an invitation to join the project. Let's jump into the demo. Here we see the host to be used. The local Windows 2016 is the physical host on-premises with a 2 gig fiber channel disk as the source. We already created a Windows 2019 host VM in Azure that'll be the target of the migration. We'll open a remote desktop client to connect to the local Windows 2016 host on-premises, and another RDP to connect to the Azure Destination Windows 2019 VM. The migration will move the 2 gig fiber channel disk to an Ultra Disk attached to an Azure Cloud VM while the source disk is running an iometer application. Here's the RDP console for the Azure Windows VM. Open up a PowerShell session in both the on-premises Windows 2016 RDP window and another one on the Azure Cloud VM. Paste the copied command and run it in both PowerShell windows. Once the CMC agents are installed, they'll appear in the CDC portal and can be connected so that data blocks can be migrated from the source disk to the Ultra Disk in the Azure Cloud. Now we're going to connect the two hosts by clicking the H2H connection tab in the CDC web console. Once connected, either side can send data to the other. In this demo, we'll use the on-premises host agent as the source and the Azure VM host agent as the connection destination. Here, the destination address is the IP address of the VM in the Azure Cloud. We'll now go to the host deployed screen and open up the on-premises host to create the migration session. Now click the New Migration Session button to open up the Migration Sessions page. Since there are no migration sessions yet, we'll use the red button to create a new one. Click the New Migration Session button. Select the on-premises Windows 2016 host as the source, and click Continue. Select Remote Migration and select the destination, which is the Azure Windows 2019 instance. Select the option to migrate data volumes only, and click Continue. Select the device to be migrated to Azure. Then click the Auto Allocate Destination red button at the top right. We've already created and configured the integration for Azure Cloud. And select Ultra Disk Storage from the drop-down list, then click Continue. Since there's no destination volume yet, we'll use the Azure Auto Allocation plugin to create the destination volume. We'll migrate the source 2 gig fiber channel disk to an Ultra Disk on Azure. Once all the remediation steps have been completed, a new 4 gig disk, the minimum for Azure, appears in the Computer Management window in the RDP terminal at the Azure Windows VM. Click Continue. So now the newly created destination managed disk is discovered automatically and is already paired with the source fiber channel disk. Now we're going to continue creating the migration session by entering some information: a short description of the migration, the periodic sync interval, and the impact level. Next, we'll select the migration parameters. IQOS is Cirrus Data's intelligent quality of service. It automatically throttles back the migration when the source volume becomes more active and opens it up when the source volume is less active. Now we'll select the appropriate IQOS level for this migration. We can choose from minimum impact, moderate, aggressive, or relentless. For this migration, we'll pick moderate. Click Create Session to start the migration. Here's the dashboard to let you know how the migration is going. We can observe the migration progress and host details. We can also see changes, migration rate, and the remaining data to synchronize. The migration session is created and is started. After the initial sync is complete, every 5 minutes, CMC will perform a resync. We can see the migration in real time by pressing the Progress button. We know that there's an iometer application writing I/O to the source disk. To see the dirty blocks during this migration, we can click on the Changed Map Data. Observe that the dirty blocks are tracked and shown here as blue dots as we add database records. We can see how IQOS throttles back the migration when the production workload is increased with the progress graph. IQOS can be modified on the fly as the migration progresses. Once all the dirty blocks are migrated, the migration is paused until the next synchronization time cycle, which can be scheduled automatically, We've selected 5 minutes in this case. Using this periodic replication, we can update the destination disk in an ongoing manner. Next, we'll move to finalize the migration. The next step is to trigger cmotion. Cmotion is used to swing the workload over from the original source fiber channel disk on-premises to the new destination VM disk in Azure. For the case of remote migration, where there's a new host VM at the cloud that is pre-configured to run the migrated workload, cmotion effectively eliminates the final sync. To prepare for the final cutover, cmotion can be triggered. In this state, reads and writes to the source disk are redirected to the destination. The source disk, in fact, becomes quiesced, and the destination disk is up to date with all current writes. Once triggered, cmotion syncs the dirty blocks to the destination. Now the source and destination are identical, and the workload is swung over to the destination. Now we're going to complete the final cutover. To finalize cutover, we'll stop the database at the source, unmount the source volume to make sure it's properly quiesced and is in a consistent state. Then we'll open Session Actions and select Finalize Cutover. Note that this step is immediate, and there is no final sync because cmotion already ensured that all the updates were redirected to the destination. This allows the Azure host to mount the migrated disk for production use immediately. When performed automatically using a cutover script, downtime for the database is seconds, not tens of minutes or even days as required by other migration methods to do a final sync. Once finalized cutover is completed, open Disk Management in Computer Manager and rescan all the devices. The new 4 gig volume is detected. We can open a new file manager at the Azure VM and observe that all the files in the Ultra Disk partition are the same as the files observed on the on-premises Windows install. This concludes the demo. What we've just shown is that you can move block workloads from any on-premises block source to Microsoft Azure while the volumes are running with no application impact, fully data reduced and encrypted, and with minimal application downtime at final cutover. This patented solution is key for everyone moving to Azure.